So previously in our previous classes that we had, we worked with the geometry of straight lines, worked with introductions and also the question papers, which is important. And now we need to consider on a new chapter or on a new topic, which is to consider the geometry of 2D shapes. All right, so what is it that we are now considering, which is different from what we had before? We are now referring to the geometry, but of 2D shapes. So this is what is important. We had a geometry before, but it was of straight lines. We considered the same geometry before working with the straight lines. But this time, as we can see, it's no longer a line. We are talking of the 2D shapes. Okay, so the first thing is, what is it that you are considering there as the 2D shapes? What type of shapes are we considering there? So if we consider the 2D shapes, these are simply plane shapes. So you're going to consider plane shapes. All right, so these are plane shapes. But what type of plane shapes? That only have two dimensions. That only have two dimensions. From the word that we are seeing in this case, two-dimensional, 2D shape. So they must have two dimensions. That is of what? Of length and of width. So we are going to consider the length and the width as our dimensions. Then 3D, we're going to talk about that later on when now we talk of the solids. So actually, when you're talking about 3D, those ones which occupy a shape in space, which occupy space. That is where we consider solids in that case, the ones that consist of the length. There is also the width there, and there is what is called the height, 3 dimensions. But in this case, we are not talking of that. We are talking of where we consider two. So in our syllabus or working to our teaching plan, what is it that you're supposed to understand? It's not like you have to work with a lot of things. No. So you can consider the examples. In this case, definitely we're going to talk of triangles, all right? Talking of triangles, that is the triangle. You can talk of a square, or guys, all those square, the rectangle. In case, let's just say all polygons. We're going to talk of the polygons that we have, a square, the rectangle, all these. They are going to be considered as part of our two-dimensional. But in this case, what is important for you to understand are the properties or to classify the 2D shapes in terms of the triangles, which means we are talking about the types of triangles. Mostly in our syllabus, they need you to understand the types of triangles. Which triangles are we talking about? What is a triangle? Remember from a grade 7, a triangle has got 3 sides like this. It's a closed figure. Remember, a polygon is supposed to be a closed figure, a closed shape. So in these triangles that we are having, they can differ in terms of the angles that are being given. They can differ in terms of that. They can differ in terms of the sides. So it depends with what you are given there. All right, what I'm simply talking about is that let's consider a scalene. All right, I talked about this in another class when we had, remember when we had the properties of triangles under the geometry of straight lines, where we had to consider 1 or 2 things there. So if you still remember, it's okay. So we've got a scalene. This one, we are going to see that all the sides that are there, they are not even same. There's nothing to consider about these sides. sides are not the same. All sides are not the same. They are not equal. All sides are not equal. All right. So in this case, all sides are not equal. So if all sides are not equal, it means also the angles, all angles there are not equal. So you can just call it A or 1, whatever that you understand, guys. For B, we also have what we refer to as an isosceles triangle. All right, that's another special type of a triangle because it has some special properties. There is nothing there. Guys, the sides are not the same, so there's nothing that they will ask you about, maybe just to identify it. All right. So, like I said, we also have an isosceles triangle, which in this case, when considering an isosceles triangle, we have got two sides which are equal. Two sides like this. So you'll be given maybe this side and this side. This is the indication, this one, that the two sides are the same. If I indicate with one, I must also indicate with one here, okay? Let's say I want to indicate that these two sides are also equal. I can indicate with two lines like this. Also here, I must indicate with two lines. This must be the same as this one to show that the sides are the same. The moment that I indicate like this, I put one here and I put two here, it shows these two are not the same. That is why you see here, I put one here, two, here, three. This is to show that all these sides are not equal. Okay, but if I put like this, just this one and this one, it shows that these two are the same. So be very careful. If you put one, this must also be one. If you put two here, this must also be two. Meaning to say, if you put three, these ones also must be three. You must be careful on that presentation. All right. So in this case, you might find question papers putting one, or they might put two like these, or they might put three, depending with the illustration that you're given. What the number that are given there shows the indication that the sides are the same. All right. That is what you can be given in terms of what? In terms of the sides. All right. Remember what I said before about this isosceles triangle, that from these two sides, which are equal, the angles that we have here must be equal. The angles that are opposite to these sides. So we refer to this angle and this angle being equal. All right. So also in terms of angles, I can indicate that the angles are the same. By this, I can put two here and also put two here. This is to show that there's something about these angles there. All right. So that is what we can do. So we can just put it like this, then also like this. The angles that are opposite the sides are supposed to be equal also. So these are the properties of what? An isosceles triangle. We are referring to two sides are equal. All right. So there we are going to have two sides are equal. So in terms of the sides, you also consider the angles. All right. Then angles opposite, angles opposite equal sides. Remember we talked of the equal sides before? So the angles that are opposite these equal sides are equal. All right. So angles opposite equal sides are also equal. So this is what is important. Okay. So that's the property of a triangle, which is called an isosceles triangle. Then another one, which is also important for us to understand, is the equilateral triangle. So we also consider the equilateral triangle. Remember, I also talked of the properties of a triangle. Angles in a triangle, any triangle that you can talk of, the angles that are inside, they add up to 180 degrees. We talked about that, which is important for you to also understand in this part. So it's just another property which is important also for you to understand. But all right, let's consider our equilateral triangle. What is it that we have? In this case, all sides are equal. All all sides equal. So like I said, if I indicate 1, this must also be 1, this must also be 1 to show that these sides are equal. If I indicate like that, I can indicate 2 here, 2 here, 2 here. This is to show that all the sides are equal. And it follows that also on the angles that we have, all these angles will be equal. And like I said, since angles in a triangle, they add up to 180 degrees. And these are 3 angles, 1, 2, 3. We are talking of what? 3 angles there. So you can simply divide 180 degrees divided by 3. That is going to give us 60 degrees. Why dividing by 3? Because there are 3 angles which are equal. So we divide by 3. So meaning to say each angle is going to be of 60 degrees, 60 degrees, 60 degrees. So whenever we see a triangle like that, which has got 60, 60, all the 3 angles, that's an equilateral triangle. So we are talking of all the sides are equal. All sides are equal in that case. Okay, which is the same thing as the angles, all angles. Okay, so we talk of the angles in this case, all angles are equal. So meaning to say they will be of 60 degrees each. So these are the major types of triangles that we need to understand: the scalene, the isosceles, and equilateral. The major part that you need to know, important part. Yes, we can have this as another indication of a triangle, but it is, or it can lie into one of these. It can be isosceles, it can be scalene, it can be isosceles, it can be an equilateral, depending with what you are given. All right, so these triangles, they depend. You must consider that. All right, so let's also consider a right-angled triangle. It's another part that you can just consider as an important triangle to be considered in our syllabus. That is a right-angled triangle. What is it that we are considering here? Right-angled. Remember, when you're referring to angles in your grade 7, you are naming the angles. A right angle is where you see this indication of a right angle, this indication of a box like this, which is showing a 90 degrees, a right angle. If the angle is given like this, you must also be able to tell what type of an angle is this. Remember, an obtuse angle. If the angle is like this, you must also be able to tell it's less than 90 degrees. So we are talking of what? An acute angle. So we've got an acute angle. We have got a right angle. All this, you're supposed to know this. We've got an obtuse. So the type of the angle affects the type of the triangle. Take note. The type of the angle affects the type of the triangle. So when I'm saying a right angled, it must have a right angle. It must have a 90-degree angle. So that's a right angle triangle is simply like this, where there is a 90 degrees. So a right angled triangle can be a scalene. It can be an isosceles, but it cannot be equilateral. What am I trying to say is that we can have a right angle triangle where these two sides are equal. Okay? We can have a right angle triangle where these sides are not even equal. That means it's a right angle triangle being a scalene. If these two sides are equal, it's a right angle triangle being what? An isosceles triangle. All right? So it can be a right angle triangle being an isosceles triangle at the same time. You must be able to understand that. So like I say, the type of the angle influences or affects the triangle that you are given. So if I'm given a right angle, I can also be given an acute angle. Remember I said this is acute. So we can also be given an acute angled triangle. We can also be given an obtuse angled triangle. But the major part, like I said, will be on a right angle triangle, but it can be any one of these All right, so just make sure you go through properties of triangles. That's the major part that we had in this class, which is important. So in this exercise, we just given just one or two questions to consider. We are given the types of triangles, all right? Naming triangles according to their sides, Number one, copy the table and match the name of each of the triangle with its correct description. There we are given name of a triangle and a description which does not match exactly what you're given. So we're supposed to redo this. All right. So they have isosceles triangle. Okay. All sides of the triangle are equal. No, that's not. Okay. None of the sides of the triangle are equal. No, that's not. In an isosceles triangle, two sides of the triangle are equal. That is correct. So this goes with the isosceles triangle. Remember, this is it. Two sides are equal. That is what we have here. Two sides of the triangle are equal. So that's an isosceles triangle. All right. Let's move on to a scalene triangle. Okay. The description. All sides of the triangle are equal. No, that's wrong. Scalene. No. None of the sides of the triangle are equal. That is correct. None means what? All, not. All sides are not. They are not. So none of the sides are equal. So that's an scalene was going to match exactly with what we have there. None of the sides are equal. All right. So let's move on to the last one, which is an equilateral triangle. All the sides of the triangle are equal. That is correct. That is exactly what we had. All sides are equal. So you were going to write this matching to this one. All right. This here matching to this one. And as we can see, the scalene is matching direct to its answer. All right. Number two, name each type of the triangle by looking at its side, by just looking into this. Okay, there we are given. Okay, let's try to have it a little bit like this. All right, the P, I mean, 1, 2, 3, 1, 2, 3. They're the same. This is to indicate that these two sides are equal. Two sides are equal. So what type of a triangle is that? That's an isosceles triangle. So you are referring to an isosceles triangle. All right. Sorry, that's an isosceles there. An isosceles triangle. That's what we have. This time there are two here, there are two here, there are two here. All the sides are equal. So if all sides are equal, what is it? That's an equilateral. All right. That's it. Okay. That's an equilateral triangle. All sides are equal. Remember what I said before about the equilateral. Here, all sides of the triangle are equal. There, we do not have any indication. This side is not equal to that. So what type of a triangle is that? All sides, none of the sides are equal. That's a scalene. So in this case, it was going to be a scalene triangle. That's a scalene. So by just looking into the triangle, you must tell with what you are given. So like I said, these indications on sides shows that the sides are equal. Okay? That is what is important there. Naming triangles according to their angles. This is the part where I was talking about the acute, whatever that you have. If a triangle is going to be like this, it's going to be an acute angled triangle. If you join it like this, it's going to be a right angled. If you join it like this, it's going to be an obtuse angled triangle. So you must also be able to tell all that in your revisions. So that is it, guys. For Meson African motifs, we shall have more questions as we continue with our topic. So make sure that if you are new, you subscribe so that you do not miss any of the classes that we shall have from Meson African Motifs till we meet again.